Okay, let's try another example. So we need to prove that 2 to the n plus 2 plus 3 to the 3n is divisible by 5 and all the normal stuff, n is contained on a set of all integers, and n is greater than or equal to 0. So we're going to approach this like we did the last one. We're going to call this our Pn, and then our P of 0 is where we plug in 0 to this and check that that is true. So I'm just going to plug in 0. Did that kind of backwards, but same idea. Okay, so it's going to be 2 squared plus 1, because 3 times 0 is 0, 3 to the 0 is 1. That's 4 plus 1, which is 5, and 5 is definitely divisible by 5. Now, since we proved the first case to be true, we're going to assume that pk is true. And just to be clear, pk is 2 to the k plus 2 plus 3n. And since it's true, we know that it can be represented by 5 times some integer. Okay, now if we're assuming that pk is true, we're going to try to prove that pk plus 1 is true based on knowing that pk is true. So we're going to say 2 to the k plus 1 plus 2 plus 3 times k plus 1. That was supposed to be a k right there. Okay, so now we just have to manipulate this until we can show that it's divisible by 5. So we're going to do something similar to what we did on the last one. I'm going to subtract this onto this side. So we know that 2 to the k plus 2 is equal to 5a minus 3 to the 3k. So this is going to be important in a second. Now I'm going to rewrite this as 2 to the k plus 3, 3k plus 3. And then I'm going to do a little bit of magic because I want to make it 2 to the k plus 2. So I'm going to write it as 2 to the k plus 2 plus 1. And then I'm going to write it as 2 to the k plus 2, and since 2 to the 1, plus 3 to the 3k, 3 to the 3. So we're just doing kind of the reverse of our exponent rule. And now that we have 2 to the k plus 2, we can replace that, we can replace that with this expression. So that's what I'm going to do. I'm going to bring this up here, and I'm going to replace this piece with this piece. So 5a minus 3 to the 3k times 2, 2 to the 1 is just 2, plus 3 to the 3k, and then 3 squared, or 3 cubed is 27. Alright, now we're going to distribute the 2 right here, so we get 10a minus 2 times 3 to the 3k plus 3 to the 3k times 27. Okay. Now we have 27 of these things, and we have negative 2 of the same thing. So 27 of those minus 2 is going to be 25. So 10a plus 25 times 3 to the 3k. And we can take out a 5 from both of those. We're left with 2a plus 5 times 3 to the 3k. And 5 times anything where a and k are both integers is only going to give us something divisible by 5. And so since we proved that p of k plus 1 is true when we assumed that p of k was true, we know that if we know any starting spot, that the next spot will be true. And then if that next spot must be true, then the spot after that will be true. And then the spot after that, and the spot, and that's how mathematical induction works.